So a quick video about the nickel metal hydride into lithium car CAN fooler. This device, this is the prototype I've been working on developing the code. You see I've got some breadboard here, and this is one of those cheap CAN controllers from AliExpress, and basically this just sends out a stream of packets that are missing in the normal configuration from the nickel metal hydride MCM, which the lithium ECM is obviously expecting. It doesn't get those and it throws an error. So I've made a couple of changes to the software I published just a few minutes ago on the forum, and I'll update it shortly. I just changed a couple of things, a couple of pin things to make it easier to connect up and make a little device. The best thing to do with this is to probably put it inside the MCM, which is where I put a lot of devices. It avoids cluttering up the OBD2 plug, and it means that also that the device is under control of the car and it turns on and off as the car turns on and off, and also you've got a free 5-volt supply inside the MCM. So here's an MCM I converted earlier. So you can see here we've got one of these devices. Now I've built this in a way so it can come apart easily, but basically underneath here is the CAN controller board, and then we've got the PIC on top, and this is the same as the PIC that was on the breadboard. But it's very, very simple, this little printed circuit board. I'll show you the bottom of that in a moment. There's only a couple of pins that we're actually going to be using the clock, and then we're using the SPI out into the SPI in on the CAN controller board. And there's only 4 wires to connect these two here, which you can see I've got a red pin and a black pin marked here. Just move this a little bit closer, you can see this. So the red pin here and the black pin here, that's the 5 volts that we're using. This is normally goes out to supply the phase sensors and things, but it's just a nice stable 5-volt supply, so we're piggybacking onto the back of those 2 pins. So this, we've got a red and yellow, that's plus 5 volts and ground for the circuit board and the CAN controller. And then the other 2 wires, you can see the twisted wires that are going underneath the board. They are the CAN FCAN wires, high and low. Orange is high and low is green in my configuration. Now you can't actually solder to the back of the pins for this side because they're right at the back and at the bottom, so you actually have to solder on top of the pins underneath. So you have to carefully remove the printed circuit board, but it's only a question of doing these 6 screws and releasing the voltage converters at the side. Make sure you don't bend those. Turn it over, and I've got a photograph which shows where to solder the wires to. Just have to be very careful there on the bottom of the pins not to bridge any of the pins, but you know, these are fairly cheap, and you should get another one if you needed one, but hopefully you won't break it. Obviously, like any mods, these are all at your own risk. So let's have a look at this then. So if I unplug this, so you can see there the CAN controller, I haven't made any modifications to that. That's just as is. There's no jumpers selected on it or anything, and it just I've just got it foam taped. You need to trim the back of it because when it arrives you'll find that the pins all stick up and all proud, and you need to trim all those off so it's nice and flat. Then put a bit of the double-sided tape on, and you can see where I've mounted mine. It doesn't have to be, it's pretty tight there, so just use some decent quality, quite thick foam tape on the bottom of that, and that insulates it then from the main printed circuit board, obviously, but obviously sticks it down into there, so that's all you need for that. So this is the little tiny daughter board with the PIC on it, as you can see, and I've put a right angle connector on. That's basically just so I could take it apart so I could show you, but you could make it much lower than this. So it fits in lower on top of there, but basically there's the PIC oriented, as you can see there, and you can see there's only one connection here from there to there, and then there's a 0.1 farad capacitor for the PIC just to smooth the power supply. So if we turn this over, so this is the if you like the layout of the strip board underneath. You can see the cuts I've made, and you can see there's one bridge here, one solder bridge here. That's the plus 5 volts. Comes in this wire here and then jumps over to the next pin down. But you can see where I've made cuts so that there are no connections, and you can see where the connections are there. So that should be good enough for you to do that. If you freeze this at this point, you should be able to make your strip board look the same as mine. And obviously there's one pin not used at the bottom down there. So if you turn it back over, you can see the orientation, so just be very careful with the orientation, make sure you get that correct. And then once you've done that, You'll see we've got plus and ground here, and obviously that goes to these two pins on the end here, plus and ground. And if we look at the controller board, it says VCC and ground, so that's plus and ground. So we can just then plug that straight back onto there. So there we are. That is the CAN fooler, if you like. So basically this transmits a constant stream of packets. In this particular case, it's the ID is hex 1E2, and it just transmits continuously a known good packet with a rotating check byte on the end, and it does all the work. The PIC does all the work sending it to that, and it just dumps it onto the FCAN. So it's pretending basically to be an OEM Lithium MCM in the back here, and sending data which would otherwise be missing with the purely nickel metal hydride MCM. So the cover will go back on in this. If you build it exactly like I've made it here, you could put another little piece of foam on the back of this if you wanted to. Just gently press down on that, it would stop that moving around, and that's basically it. So that's the modified MCM for the nickel metal hydride to lithium testing and conversion. If you want to dump a nickel metal hydride pack into a lithium car, this should help you get rid of the check engine light. Like anything, there may be hidden issues that we're not aware of yet, and something might spring up and bite us, but we don't know. We haven't found anything particularly at the moment, and I haven't tested this in my car because at the moment I'm back to lithium because I'm away next week for a holiday. So that's where we are at the moment. Hope that is useful. I'll update the thread with details later, probably tomorrow.